Good morning everyone and welcome to my YouTube channel. So for today we are going to be doing introductory physics and chemistry, which are units and measurements. So the first thing that we get to define are what we call physical quantities. So what are physical quantities? So just as the word entails, physical quantities are measurable features or properties or objects. So this is what we mean by physical quantities. So they are measurable. For example, if you are to measure the speed of a moving car, that is something that you can measure, or the area of a football pitch. So you can measure the area. So that is what we call measurable features or properties of objects. Now, we also have the non-physical quantities. So the non-physical quantities are things that are hard to measure. The examples of these are, let's say when we talk about love, no matter how much someone may tell you to say I love you a 10 out of 10, that's simply a lie. So love is something that is very difficult to measure. Love, we might have hatred. In other words, mostly emotions. These are non-physical quantities. We cannot quantify them. Now remember, whenever we are trying to measure something, there is need for us to come up with the measurement, let's say 20. Now, to avoid ambiguity in the science community, there should be units. Like, what are you talking about? 20 watts. We might talk about 20 kg. We might talk about 20 meters. So now this kg or the meter, what are they called? Now scientists came up with one language to suit the whole entire scientific community, which we call the SI units, of measurement. Before we go deeper on the SI units, let's come up with what we call the base and fundamental units. So when we talk about the base and fundamental units, we are just talking about those units that are independent. So you don't need other units in order for, let's say, to measure the temperature. So you just say the temperature direct to say if the temperature is 20 degrees Celsius, 20 degrees Kelvins, it is just that. If you have to measure, let's say, the length of something, you just have to measure it direct. So in other words, the base and fundamental units are independent of other units. So this is our definition. Our base or fundamental units are defined by some physical property and not in terms of other units. So what we simply mean to say is that these fundamental or base units are independent. So let's say, for example, when you just say the meter is something that is just direct for, let's say, the physical quantity which the meter measures is what we now call the length. So if you talk about your length, then the SI units, those SI units are independent. So these physical quantities, which are fundamental or base quantities, are also independent. When you have to talk about the length, it is something that you can just measure direct without considering other factors. Like, let's say, for example, if you have to measure the mass, you just have to use a beam balance. From there you will get your mass, and also other things such as the time is just something direct. You just have a watch, your press. So it is independent of these other things. We will understand more as we look at our derived quantities. So now there are seven fundamental physical quantities. So now there are 7 physical fundamental quantities. So I've made a simple mnemonic. So this mnemonic goes by the word just metal. So double T and double of L. So these are the 7 fundamental physical quantities, which are: number 1, we have M for mass. Then when you look at your E, that's for electric current. When you look at your T, 1 is for temperature. When you look at your other T, 1 is for time. When you look at for A, that's your amount of substance. When you look at this one, L is for length. The other L is for luminous intensity. So these are the 7 fundamental physical quantities. Let us now look at their SI units in table form. So let's say we have these. So using our mnemonic which we have made, which we are calling metal. So our M is for mass. Our E is for electric current. So we have double T. We have our time. The other T is for temperature. The A is for amount of substance. Then our L is for length. So we should have double L on our mnemonic, just as we did before. Then we have the other L is for luminous intensity. So these are what we have. Now to look at our units, for the mass we are going to have the kilogram. For the current, we have the ampere. For the time, we have the second. For the temperature, we have Mr. Kelvin. For the amount of substance, this is the mole. For the length, we have the meter. For the luminous intensity, we have the candela. For our symbols, the mass, kg, 2 small letters. We have the ampere, we have big letter A. The second, we have small letter S. Kelvin, we have big letter K. For amount of substance, which is the mole, we have MOL. So this is the symbol for the mole. Then for the length, the meter, we have small letter M. For the candela, we have big letter C, small letter D. So these are our physical quantities. So we are now on derived quantities. So the derived quantities, these are dependent on the fundamental physical quantities. So these are our derived quantities that are dependent in terms of other quantities. Like for example, if we talk about, so they mainly depend on fundamental quantities. Let's say we talk about the area. We know that the area is equal to length times length. So already this is a derived quantity because it depends on 2 physical quantities, though the same. We have the length. So if we are to have the units, sometimes you may be asked that the units, we know that if we have the length, we can put our meter like that. Then if we have another length, we can put our meter like that. So meter times meter will give you the meter squared, which can be written in words first. We have the meter squared like that. So this is the area in terms of the fundamental quantities. So now the other one, let's say we are looking at momentum is also one of the derived quantities. So the momentum is defined as the product of the mass and velocity. So mass times velocity gives you the momentum. We know the SI units for velocity is the meters per second times the mass, which is the kg. So that's how come we have the kg. If we multiply kg times meters, so it will be kg meters per second. So this is our momentum. So the momentum is the product of mass and velocity. Other fundamental quantities, though we are not going to write their units, we might have the force. The force is also dependent on the mass and the time, or rather the acceleration. We have other fundamental quantities such as power, which is the rate of doing work. We have other fundamental quantities. For example, we might talk about the pressure, which is the force over area. We might talk about a lot of things. We might talk about work. We might talk about energy. We might talk about the frequency. So as long as it depends on some fundamental quantities, then that means to say that is what we call derived quantities. Thank you very much for watching the video. Hope you would like, subscribe, and share for more.